Today we're going to be talking about how to find vector and parametric equations, and in this particular problem we've been asked to find vector and parametric equations for the line which passes through the point 1, 0, 6 and is perpendicular to the plane x plus 3y plus z is equal to 5. Now as a reminder, we're going to be using this formula here for r, where r is equal to r sub 0 plus t times v. We need to plug in vectors for r sub 0 and for v. T is going to remain as a parameter value in our equation for r. Now I don't want to get too much into this formula, but you can derive this formula as a result of the definition of vector addition or the triangle law, and the result for us, the value of r that we get, is going to give us the vector equation of the line. So that's going to give us the first half of our problem because we've been asked to find the vector equation of the line, this line which passes through the point and is perpendicular to this plane. So to unpack this problem, the first thing we need to realize is that we have a line, so some line, we'll call it L. It passes through the point 1, 0, 6. If we want to define this point as a vector, we can call it 1i plus 0j plus 6k, which we can simplify to just be I plus 6k, which defines that point as a vector. We also know that the line is going to be perpendicular to this plane, x plus 3y plus z equals 5. Well, if we have a line that's perpendicular to a plane, what else do we know about that line? Or what other concepts are related to being perpendicular to this plane? Well, remember that we have the concept of a normal line, and a normal line is going to be perpendicular to any plane that we have. We just have to find the associated normal line. The way that we can do that is by taking the coefficients that we have here on x, y, and z. So because we have our plane in this form where we have our x, y, and z terms on the left equal to some constant on the right, we can just take the coefficients here on our x, y, and z terms and put them in vector form. That actually gives us a vector equation for the normal line. So what we can do is take here, this is essentially 1x and 1z. So the normal line we can define as the vector 1, 3, 1. That's going to be the vector that defines our normal line. Well, because the normal vector is perpendicular to the plane, and we're looking for a line which is also perpendicular to the plane, we know that our line is going to be parallel to the normal vector. So instead of now looking for the line which passes through this point and is perpendicular to a plane, we can instead think of this problem as being the line that passes through a point and is parallel to this other vector. That simplifies things because now we're just dealing with a point and a line instead of a point and a plane. It's especially convenient because to use this formula for the vector equation of the line, I need here a point that the line passes through. I can substitute the vector representation of the point for r sub 0, and I need a vector which is parallel to my line to substitute in here for v, and I have both of those things now. So here's what I can do. I can say r is equal to, I'm going to plug in this 1i plus 0j plus 6k for r sub 0, and I'll say I plus 0j plus 6k, plug that in for r sub 0. Remember, my t value is going to stay as a parameter, and in for v, I'm going to plug my normal vector here, which is going to be I plus 3j plus k, like this. Now all I need to do is simplify this equation by grouping my components together. I want my i's together, my j's together, and my k's together. So here's what that's going to look like. For I here, I'm going to have I, and then I'm going to distribute this t across my I plus 3j plus k, and then group them with the terms from my first vector. So I have I for my first vector, I have ti for my second vector, so I'm going to say plus ti here, and I'm going to kind of group these together like this. Then for j, I'm going to have here 0j plus 3tj, because I'm going to distribute this t across the 3j. I'm going to get 3 times t times j like this. Then for k, I'm going to get plus 6k plus t times k, which is just going to give me tk like this. Now what I want to do is factor out an I, factor out a j, and factor out a k from each of these terms. So when I factor out an I from my first grouping here, what I'm going to be left with is 1 plus t, and I pull the I out and put it here at the back. When I factor out a j from this second term here, I'm just going to get 0 plus 3t. I can just call it 3t times j like this. And then when I factor out a k, I'm going to get 6 plus t times k. And this is the form in which I want my final answer. This is what we call the vector equation of the line that passes through this point and is perpendicular to this plane, or we can also say parallel to the normal vector 1, 3, 1. So that's my vector equation of the line. Now I just need parametric equations for the line. And parametric equations are going to come really easily once I have the vector equation of the line, because all I do is take the coefficients here on my I, j, and k values. So I'm going to take this 1 plus t in front of the I, the 3t in front of the j, and the 6 plus t in front of the k, and put them into my parametric equations. Remember that I, j, and k correspond with x, y, and z, essentially. So what I'm going to call my parametric equations then here, we'll just say parametric equations. I'm going to get x equals 1 plus t, that coefficient value I pulled out from in front of the I. I'm going to get y equals 3t, and I'm going to get z equals 6 plus t. And that's it. These are my parametric equations for the line. These are the parametric equations that define this line. And I have, of course, the vector equation that defines this line. So that's how you find the vector and parametric equations when you've been given a line that passes through a point and is perpendicular to a plane.